In this video, we're going to focus on addition and subtraction equations and how you would solve addition and subtraction equations. So the first thing we're going to look at is the difference between an expression and an equation. So if you take a look, what we've reviewed before are our expressions, and our expressions have no equal sign, but they do contain, or they have, numbers and symbols. Remember that they could have more than one operation going on, and that would be when we would use order of operations to solve our expression. We may also have expressions that contain variables as well, and those would be our algebraic expressions. When we're working with equations, for the most part, an equation is going to have a variable, and that's why we're solving it. So with an equation, the first thing would be that it has an equal sign. And we kind of see that in the word equation with equa. Okay, so that looks similar to equals. So we know that it's going to have an equal sign. Second thing that we want to take a look at is that with an equation, we are solving for something. We're solving for the variable or the letter. So because we're solving for the variable or the letter, that means that we are going to have to use operations to help us solve the equation. So if I give you an example of each, if we look at an expression, 2x plus 4 would be an expression. And then if I gave you another an equation, I could say 2x plus 4 equals 7. And the difference between the two is that in 2x plus 4 equals 7, there's an equal sign, where in our expression of 2x plus 4, there is not. So let's take a look at writing addition equations. So this video is going to be split into two parts, writing addition equations and then writing subtraction equations and solving them. So the main thing that you have to remember when we're writing equations is that we have to keep in mind that there's going to be something missing. So for example, if we read through this problem, it says George has some plastic figures. After he bought 7 more figures, he had 25. How many plastic figures did George have before he bought more? So the first thing I notice is that he bought 7 more figures, and that tells me that he had 25. How many plastic figures did George have before he bought more? Well, right away my mind goes straight to using subtraction to solve this. When you're writing an equation, you need to work backwards. So if I think I'm going to use subtraction to solve it, I need to actually write an addition equation. So if I look up here and I reread this, I see after he bought 7 more figures. Well, if I'm buying 7 figures, that tells me that I'm adding 7 figures to my collection. And then I know he now has a total of 25. So that tells me that my equation is going to be equal to 25. How many plastic figures did George have before he bought more? This is what's missing. This is my variable right here, because this is what I don't know. This is what I'm trying to figure out. So I see that phrase, plastic figures. So I'm going to actually use that to help me identify my variable. And I'm going to make my variable the letter F for figures. So I'm going to go ahead and add the F to my equation. And I'm going to see that F plus 7 equals 25, where my F represents the plastic figures that he had before he bought more. So this would be my equation for this example. If I take a look at the second example, it says Andy had some baseball cards. After he bought 12 more cards on Saturday, he had 48 cards in all. How many cards did Andy have at the start? So that should say Andy. So Andy had some baseball cards. He bought 12 more cards. He now had 48 cards in all. How many cards did Andy have at the start? So again, I would automatically think of a subtraction problem to help me figure out how many cards he had at the start, but I need to do the opposite of that. So I would need to add or write an addition equation. So if I take a look at my wording, I know I see this bought 12 more cards. So if I'm buying 12 more cards, that means I'm adding 12 to my collection, and it tells me now that he has 48 cards in all, so I know my equation will be equal to 48. Seeing that my variable or my missing piece is right here, how many cards did Andy have at the start? I'm going to identify my variable as C for the cards that Andy had at the start. So I'm going to replace or fill in this blank with the letter C. So now I know that I have how many cards at the start plus 12 more equals 48. So C plus 12 equals 48 will give me my addition equation for this particular problem. Now we're going to take a look at solving addition equations. So before we wrote some equations and we could have solved them, but we weren't there yet. Now we're going to take a look at solving addition equations. When we're looking at solving addition equations, we want to make sure that we are following the same steps every time. So the first thing that you're going to want to do is you want to think about the equal sign as kind of like a balance. So the left side of your equation has to be equivalent to the right side of your equation. So what I like to do is I like to draw a line down through my equal sign because that shows me that this x plus 5 is going to be equal to 11. So now what I'm going to do is I'm going to use the inverse operation. So we're going to keep that in mind, inverse operation. And what that means is I'm going to use the opposite operation of what's happening in my problem. So if I look at my problem, I'm adding. So the inverse operation would be using the idea of subtract, and I'm going to subtract 5 from both sides because remember I have to keep my equation equal or balanced. So if I look at this, I have plus 5 minus 5. That cancels, and I'm left with x. So now I have an x on my left side, and x would be equal to whatever 11 minus 5 is. Well, 11 minus 5 is 6, so x would be equal to 6. How do we check? We would now go back and we would replace x with a 6. So to check, we can do 6 plus 5 equals 11. If we add 6 plus 5 together, we get 11, which would be equal to 11. So our answer is 6. So in our first example, x would be equal to 6. Moving on to the second example that's on your paper, we have 6.2 plus f equals 11.7. So again, I'm going to draw my line down through the equal sign so I know that both sides have to be equal to each other. And I'm going to look, right now I'm subtracting, so I need to use the inverse operation or the opposite operation. So I need to subtract 6.2 on both sides. When I subtract 6.2 from 6.2, they become 0. So I would have f equals 11.7 minus 6.2. So 7 minus 2 is 5. Bring down my decimal. 11 minus 6 is 5. So f would be equal to 5.5. I can then go back and check. So I can do 6.2 plus 5.5 and hope that I get 11.7. 5 plus 2 is 7. 6 plus 5 is 11. Bring down my decimal. So 5.5 would be my answer for this equation. So f would be equal to 5.5. Our final example is now looking at a fraction. So notice that I already did an example with a whole number and a decimal. Now I'm going to look at using fractions. So again, I'm going to draw my line down through the equal sign. I'm currently adding, so I'm going to subtract because that's the inverse operation. So I'm going to subtract 4/5 from both sides. This cancels, so I'm left with g equals 1.5 minus 4/5, which using my calculator would get me an answer of 7/10. So g would be equal to 7/10. Moving on to our subtraction equations. So this is going to be an example, or this example and the next example will be how you write subtraction equations. So it says Clive is 19 years younger than Josh. Clive is 34. How old is Josh? So again, I'm thinking about what do I know? If I look at the fact that Clive is 19 years younger than Josh, that tells me that I'm subtracting by 19. Clive is 34. Is represents my equal sign. So that tells me right away that my equation will be equal to 34. I'm trying to figure out how old is Josh. So this would be my variable, so I'm going to use the letter J to represent Josh, and I'm going to fill that in my blank. So my equation for solving this would be J minus 19 equals 34, and then I could go ahead and solve it. Taking a look at our second example, writing subtraction equations, Amy made muffins for a bake sale. She sold 28 muffins, leaving 20 more to sell. How many muffins did Amy bake for the sale? So if I think about this, we know that she sold 28 muffins. So that right away tells me that I'm subtracting 28 away from my original amount, and it's leaving 20 more to sell, so it would be equal to 20. From there, my question is how many muffins did Amy bake for the sale? I'm going to use the letter M to represent the muffins that are missing, and I'm going to replace that at the beginning. So that would tell me that my total amount of muffins, so total muffins minus the muffins sold equals the amount left. So this kind of breaks it down for you. This M minus 28 equals 20 would be our final subtraction equation for this example. Now let's take a look at how we would solve subtraction equations. So think back to how we solved addition equations. We're still using that idea of the inverse operation. And in this case, with the inverse operation for subtraction would be addition because that's the opposite operation. So if we think again, opposite of subtraction is addition. So in this case, we would draw our line down through our equal sign, and in this instance, we would add 5 to both sides. 5 minus 5 is 0, so we're left with an x. 8 plus 5 is 13, so x would be equal to 13. We would then check, so we'd replace x with 13, and we would do 13 minus 5 equals 8. If we actually solve 13 minus 5, that's 8, and 8 is equal to 8, so our answer would be x equals 13. Taking a look at our second example, again drawing the line down through the equal sign, we're going to add 3.4 to both sides, because again we're using the inverse operation. 3.4 minus 3.4 equals 0, so we're left with f. 9 plus 3.4, we're going to add a decimal and a 0. 0 plus 4 is 4. Bring our decimal down. 9 plus 3 would be 12, so f should be equal to 12.4. And finally, with our last example, we are going to draw our line down through the equal sign, and in this case we are still adding because we're working with subtraction, so the opposite of subtraction is addition. We're going to add 1/3 to each side, so 1/3 minus 1/3 cancels. We're left with g, and then 2 1/4 plus 1/3. I'm going to pick up my calculator, and I'm going to type that in on my calculator and get 2 7/12. And that would be my final answer, so g would be equal to 2 7/12. So just a couple reminders when we're working with equations. Equations have an equal sign. They represent the solution to an unknown situation or to a variable. And to solve an equation, we use the inverse operation.